Is the national crime rate really going down? Some sociologists say yes. They say that the reason for the decline in crime rates in the 1980s and 1990s is demographics. It seems that the population is aging, and older people commit fewer crimes. According to the FBI and the Justice Department, 70% of all arrests are of males aged 15 to 34 years. Suppose you are a sociologist in Rock Springs, Wyoming, and a random sample of police files showed that 33 arrests last month, that of 33 arrests last month, 21 were of males aged 15 to 34. Use a 5% level of significance to test the claim that the population proportion of such arrests in Rock Springs is different from 70%. All right, so our level of significance is 5%, in decimal form is 0.05. According to FBI and the Justice Department, 70% of all arrests are of males aged 15 to 34. So the null hypothesis is going to agree with that data, and that's going to give us one of these first three hypotheses. Because we're asked to investigate whether our collection of data is different, we go ahead and select the not equal to. We're going to use a standard normal since NP and NQ are greater than 5. Now, how do we check that? N is the size of our sample, 33. P is 70%. So if you calculate 33 times 0.7, that gives you 23.1, which is well above 5. Well, if 70% is the probability of success, being a male 15 to 34 years of age, then the probability of failure is going to be 30%, or 0.30. So if you take 33 times 0.30, you get 9.9. So N times P and N times Q are both greater than 5. The value of the sample statistic, we're going to go into SALT. I already have a tab open, so I'm just going to go in here. Inferential statistics. One sample proportion. Okay, so number of successes in our data, that was 21 out of 33. 21 out of 33. We're testing against 70%, and our alternative hypothesis is not equal to. We're testing different. Not equal to. Okay, so let's generate our Z statistic is negative 0.80. Negative 0.80. Our p-value, now notice our z-value, our sample statistic was 2 decimal places, so that's why I changed 0.797 to negative 0.80. Our p-value, they want it to 4 decimal places, so I'm going to copy and paste. There we go. Let's see, I better take that extra spacing out. Okay, not equal to, that's going to be a two shaded display. All right, so p-value is 0.425, alpha is 0.05, p is way larger than alpha, so that means we've got a high risk of making a type 1 error, higher than we allowed ourselves with the 0.05 alpha level. So if our probability of making a type 1 error is higher than what we're allowing ourselves, we don't reject the null. P is greater than alpha. Don't reject the null. We do not have statistical significance, and there is insufficient evidence. Remember, the wording will all back itself up. And then I'm going to submit. Let's check the answers. They're all correct. Let's do the same thing, but this time I'm going to pull it up on the TI-84. Okay, stat, test, one prop z-test, one proportion z-test. Our null hypothesis was 0.70. We had 21 out of 33 arrests that were males aged 15 to 34. Our alternative hypothesis is not equal to, so make sure that is selected. And then calculate. Our z-value is negative, and that matched with SALT. So rounded to 2 decimal places, it's negative 0.80. Excuse me. Our p-value is 0.4250. 0.4250. This p-hat is your estimate from your data. If you actually take 21 divided by 33, this is the proportion you get. The proportion we had in our data was 63 to 64%. That's from our sample. It's just not strong enough to go against the pre-existing population data. Even though 63% is different than 70, it's just not statistically strong enough to go against it. And that's why down here, when we claimed our p-value, which is probability of making a type 1 error, against alpha, our predetermined allowance, p was greater than alpha, so we failed to reject the null. We don't have enough evidence to conclude that the proportion of arrests are different from 70%. Even though our data is different from 70, it's just not statistically stout enough.